Hello. All right. So the past couple of days we've been talking about sequences and specifically yesterday and the day before arithmetic sequences. So today we need to look at how we would work with geometric sequences. And just like we started with arithmetic sequences, the recursive rule, we're going to do the same thing for geometric sequences, starting with the recursive rule. So we've got some new vocabulary we definitely need to address. We have geometric sequence, which we've actually talked about before. It's a sequence of numbers that's formed so that the difference between two terms is a constant common, and this is called the common ratio. So a geometric sequence, remember, that is when we are multiplying to get to the next term. And that's why it's called a ratio. So the common ratio is the number multiplied in a sequence to get to the next term. That's the number you're multiplying by. The recursive rule is a rule that we use to find the next term in a sequence. So all of this is old news to us. So let's get down to the new notation for geometric sequences and the recursive rule. So here I've written in your notes what the recursive rule is. So just like the recursive rule in an arithmetic sequence, we are only able to find the next term. So if we have a sub n equal to r, this is our common ratio, r, times the term before it, given that the first term is blank, whatever it is. So a sub n still means it's the nth term. A sub n minus 1 is still the previous term. R is still the common ratio, and a sub 1 is still the first term. That is all old. Okay, so let's try an example. So we need to find the first four terms in of the sequence that's given to us. So let's look at A to start with. Example 1a. So we are given that our first term, a sub 1, is 3, and r, our common ratio, is 2. So what this means is for our first term, a sub 1, we can write 3. We need to fill in a sub 2, a sub 3, and a sub 4. So what we need to do is we're going to multiply. So if our first term is 3, our second term is going to be 3 times 2, which gives us 6. So we can write 6 on our line. If our second term was 6, we need to multiply again by 2 to get the next term. So 6 times 2 gives us 12. And I probably don't need to write it down, but 12 times 2 gives us 24, which is our fourth term. Okay, so we've done this before. We've looked at geometric sequences before. Now we're just figuring them out for ourselves. Okay, if we look at example 1, let's do example 1b. So we're given the first term is 256. Let's write that on our line, first line. We need to find the next three terms. Well, they give us a rule. A sub n is 1/2 of a sub n minus 1, which is our previous term. So if we want to find a sub 2, our second term, we're going to take 1/2 of the term that came before a sub 2. So a sub 2 minus 1. So this means 1/2 of a sub 1. 1/2 of a sub 1 was 256. 1/2 of 256 is 128. So we can write 128 for a sub 2. We're going to do the same thing for a sub 3. It's 1/2 of a sub 3 minus 1, which is a sub 2. I'm not showing every single step this time, which is 1/2 of 128, which is 64. And for the last term, a sub 4 is 1/2 of a sub 3, the term that came before a sub 4, which is 1/2 of 64, which is 32. Okay, so we used a rule now to find the first 4 terms of the sequence. Hopefully we're okay with that, because we are going to move on to example 2. So we're skipping example C, 1C, and we're going to do example 2A. This time we're being asked to write the recursive rule for the nth term of the geometric sequence and then find a sub 5. So this is the form that we're going to use. And a lot like the recursive rule of arithmetic sequences, a sub n is always the same, equals. And what we're going to fill in is this r, the common ratio, and the first term. This is all we're filling in. So r comes next. R is 3. So a sub n equals 3 times a sub n minus 1. Given that, and I'll just write it below, a sub 1 equals, and this is where we fill in what a sub 1 is, right here, a sub 1 equals 5. So this is our recursive rule. That's it. We're done. Now we need to solve for a sub 5. A sub 5, then we're going to, in order to solve for a sub 5, we need to figure out, we knew a sub 1 was 5. We need to figure out what a sub 2, a sub 3, a sub 4, and then a sub 5 is before we can write down what a sub 5 is. Well, a sub 2, we're going to plug in 3 times the term before, the previous term. The previous term was 5. So 3 times 5. A sub 1 is 5. 3 times 5 is 15. We found a sub 2. For the next one, we're going to multiply a sub 2 by 3, the term before it. And 15 times 3 gives me 45. There's my third term. Now I have 3 times 45, which is 135. And finally, my fifth term, which is 3 times 135, which gives me 405. Yay, we did it. We solved for the fifth term. Fifth term is 405. Okay, B and C work exactly the same way. So I want to move on to example 3, where we actually have to write a recursive rule for the nth term of the geometric sequence and then find a sub 5. So we're going to write the nth rule, and this time we're not given a sub 1 or r. We need to figure out what those values are. Well, a sub 1 is just my first term. So my first term is right here. So I can just write in a sub 1 is 3. Now I need to figure out what the pattern is. How do I get from 3 to 6? Well, they already tell us it's geometric, so we know that we're multiplying. So we're going to multiply 3 by 2. Can multiply 6 by 2 by 2. So then we know r, our common ratio, the number we're multiplying by, is 2. And now I can just fill in these values where they're needed in the formula. So a sub n equals r is 2 times a sub n minus 1. Given that a sub 1 is, we have to tell them where to start. So a sub 1 is 3. There's my recursive rule. And now we need to find a sub 5. I'll do that work over here. Well, a sub 1 was 3. So now we're going to take our first term to find our second term. So a sub 2 equals 2 times whatever term came before the second term. Well, that was the first term, and that's right here. 2 times 3, that gives me 6. This is showing really the first 4 terms that are already given to us in our sequence. So I can kind of just skip down. I know a sub 3 was 12, a sub 4 was 24, and so I can find a sub 5 easy enough by just multiplying 2 times the term before it, which was the fourth term. 2 times 24 gives me 48. So let's use what we know and skip solving for a sub 2, a sub 2, 3, and 4 if they're already given to us. Okay, let's look at example 3b. For example 3b, we're doing the same exact thing. So we need to figure out what my r is and what my first term is. Well, I already know, and I can write over here, a sub 1 is 0.5. So what's r? How do I get from the first term to the second, second to third, third to fourth? What am I multiplying by? So in order to get from half to 1.5, I have to multiply by 3. It takes 3 halves to get to 1.5. It takes 3 times 1.5 to get to 4.5. It takes 3 times 4.5 to get to 13.5, so on and so forth. So my r is 3 in this case. Okay, then I just plug in the ones that I needed to for my equation, and I get a sub n equals, common ratio is 3, times a sub n minus 1, given that a sub 1 is 1/2. Okay, now since I already know the first 4 terms, 1, 2, 3, 4, I can take my rule, and I know I need to solve for a sub 5. Well, a sub 5 is going to be 3 times a sub 5 minus 1, or the term before it, so 3 times a sub 4. A sub 4 was my 4th term. That's up here. Here's my 4th term. So I can multiply 3 times 13.5. When I multiply 3 times 13.5, I get 40.5. This is my 5th term. The 5th term in this sequence, the term that comes next, is 40.5. Okay, that's everything I have for you for today for geometric sequences. Your homework is with the sub. You can work with a partner if you're quiet enough. Good luck.